Guys, welcome to Pepcoding. So in this video, we are going to discuss another new question of searching and sorting series, that is count zeros in a sorted matrix. So in this question, we'll be given a binary square matrix. Binary square matrix means you'll be given a square matrix containing only zeros and ones. Alright, where each row and column of the matrix is sorted in ascending order. Okay, now find the total number of zeros present in the matrix. So let's see. My matrix is going to look like this. Okay. So yeah, my this matrix is sorted row wise and column wise, right? Okay. This row is sorted 0 0 0, then it is followed by 1. Okay, then 1 1 1, there is no 0. It means it is sorted. This row is, if I look at this row, this is also sorted 0 0, then 1 1 1. And if I look at this column, this is also sorted 0 0, then 1 1. Okay, so this matrix is sorted row wise and column wise. Okay. Now, what do I have to do? I have to count this number of zeros present in this matrix. So what do I say? If I say I have to like count the number of zeros, right? So we have to count it in n time, right? We don't order of n time, because we cannot solve this in order of n square time. If I were allowed to solve this in order of n time, I would have run a loop, like 2 for loop, 1 for row, 1 for column, and I would check, right? If it's 0, then I would have increased the count, right? If the element is 0, I would have increased the count. So we don't have to do this. Okay, we have to do this in order of n time. So how I can do this? Let's say I use binary search. So let's say I think I should use binary search. Let's see how. Because I say I want to use binary search in this. So I say I will take this point as my mid or this point as my mid. Now see, how am I saying this thing? If I take this point as my mid, all the elements here are lesser than this point, right? And all the elements here are greater than the element at this point, right? All the elements here are lesser than 1, lesser than or equal to 1, and all the elements here are greater than or equal to 1, right? Because I cannot have 0 here, because it's a sorted matrix. So in this column, I cannot have 0. I'm going to have either a value greater than 1 or equal to 1. But I cannot have any value greater than 1 because it's a binary matrix, right? So this is going to be my mid. Or this can be my mid, because all the elements here are lesser than this point and all the elements here are greater than this point. Wait. All the elements in this row, like all the elements at this, or like here, all the elements are greater than the element at this point. All the elements here are lesser than the element at this point. Lesser than the element at this point, right? So I am going to apply binary search over this point or this point. Like this is going to be my mid. Okay. This will be my mid or this will be my mid. That is, either my top left would be my mid or my top right would be my mid, or my left bottom would be my mid. Okay. So now I take this point as my mid only, right? So let's say initially my j is here and my I is here, right? That is, my row number is 0 and my column number is what? Mat dot length minus 1, that is equals to 4 here. Okay. So I am at this element initially. So I check now if what is the value of my mat of ij. Okay. My mat of ij is what? My mat of ij is 1. Well, now if it's 1, what does it mean? It means if I have 1 at this position, right, then all the elements after this element in this column are going to be greater than 1 or equal to 1. So I'm not going to find any 0, right? If it is 1, then all the elements after this are going to be 1, right? Because it's a sorted column wise sorted matrix or row wise sorted matrix. Because it's a sorted matrix, it is going to be greater than or equal to 1, right? So this column is now useless for me. I don't have to check all these elements, right? So what do? I decrease I jump to this column. Okay. So now I again check my mat of ij. It's again 1. What do? I know if it's 1, all the elements after this are going to be 1. So this column becomes useless for me now. right? Now I come to this column and I check my met of ij, which is equals to 0, right? My met of ij now is equal to 0. It means my index is, my j is at index, which index? 2. It means if it's 0, then all the elements before, prior to this element, like all these elements are going to be lesser than 0 or equal to 0, are going to be 0, right? It cannot be 1 because it's a row wise sorted matrix, right? So what do I say? I say I have j plus 1 zeros in this row because j is 2, so I have 2 more 1, 2 more zeros here, right? So 1, 2, 3, j is 2, 2 plus 1, we have 3 zeros in this row. So I say I have checked all the zeros for, I've count all the zeros present in this row. So increase my count, increase my row number. I'm going to check for another row. Okay. So now my j is here, my I is here. So I'm at this position. I again check my met of ij is 1. So it says now my column become useless to me. Move to another column because it become useless because it's 1 now. So after these elements, I'm going to have all the ones, right? I'm not going to have any zeros. So I don't have to check all these elements, right? So I come here. I again check, I decrease my j, I again check. My mat of ij is equals to what? It's equals to 0. See, so it again means, so I am, so initially my count was 0, then it became 3 here. It became 3. Now I again increase my count by j plus 1. So now j is what? 1. It means it has 2 zeros, right? So I increase my count by j plus 1. So that is 3 plus 2, it becomes 5. Okay. And now I move to another row, right? Right. Now it checks this element, which is again equals to 0. So I again increase my count, right, by j plus 1. So j is 0, j plus 1 is 1. So 5 plus 1, which is equals to 6. Okay. Now I again move to this row. I again found a 0. Then I again increase my count by j plus 1. So j is 0. Count plus 1 will become, it will become equal to 7. Now I again come to this row and I again check my element is 0. So I increase my count by j plus 1. That is by 1. So it becomes 7 plus 1 equal to 8. Okay. Now if I have reached my I become, here my I increase my I. Now my I become greater than mat dot length. So what do? It means I have reached my like second point, right? It means like I have reached my opposite point, right? It means I have traveled all the, I have checked all the elements, right? So what does it do? It ends the loop here, right? So now I get the total number of zeros present in my matrix. Okay. So this was my simple algorithm. Now let's try to code this. So basically what was my main thing? My main thing was to understand why I'm taking this point as mid, and we have to decrease the j column whenever j's value whenever I found a 1, and increase the rows value whenever I found a 0, right? Now let's try to write the code. I will have int count. First of all, I have a count. Okay. And I make a variable int n equals to that as mat.size. Now what do I have to do? My I was initially 0 and my j will be equal to what? N minus 1. Now I'll run a loop and check. I'll run a loop till when? Till my I is less than n and my j is greater than equals to 0. Okay. What does it do? I'll check first of all. If mat of I j is equal to 1, then do what? I comma j is equal to 1, then do what? Decrease my j, else increase my count by j plus 1, and increase my I plus 1 and return count. Okay. Return count. And now let's try to run this code. Okay, accepted, and let's try to submit this. Okay, submitted. So this was my algorithm to find the number of zeros present in my sorted matrix using binary search. So I hope you like this video, and I hope you I were able to made it clear to you. So I hope you like this video, and thanks for watching.